Hello everyone. Today we will be discussing the quick solutions of All India Akash Test Series, Test 5 Code C and D Mathematics, which was held on 3rd February 2019. So let us start with the question number 61, which says that if an is equal to limit x tending to 0, x upon sine nx, then the value of summation n going from 1 to 9, 1 upon an is, right? Firstly, let us solve the limit, that is an is equal to limit x tending to 0. If I multiply and divide by n, then we will get nx upon sine nx into 1 by n. Now, we know that limit of t tending to 0, sine t upon t is 1, right? So using this limit here, we can say that this will be equal to 1 into 1 upon n, right? So the value of an is 1 upon n. Now, the value of summation n going from 1 to 9, 1 upon an is equal to summation of n going from 1 to 9, n, right? That is equal to 1 plus 2 plus 3 up till 9. So this is an AP with common difference 1. So its sum will be n by 2 into first term plus last term, that is 10. So this is equal to 45. Hence the correct answer will be option number 3. Next is question number 62, which says that total number of unit vectors r which are equally inclined to the coordinate axis is. Now let us say the r vector have direction cosines as L, M and N. Now we know that for direction cosines, L square plus M square plus N square is equal to 1, right? Also, as it is given that the vector is equally inclined to the coordinate axis, so we can say that L square will be equal to M square will be equal to N square. So from these two equations, we can say that L square is equal to M square is equal to N square is equal to 1 by 3, right? That is L is equal to M is equal to N is equal to plus minus 1 by root 3. Hence, the direction cosines are these one. So we can say that the unit vector r is equal to plus minus 1 by root 3 into I cap plus minus 1 by root 3 into j cap plus minus 1 by root 3 into k cap. Now, in the question, it is asked that how many unit vectors are possible. Now, this can be either positive or negative. That is, two values are possible from here, and this can also be positive or negative. Hence, two values are possible from here. Similarly, two values are possible from k cap. Hence, the total number of such vectors is 8, right? So, the correct answer will be option number 3. Next is question number 63, which says that if 3 raised to the power x plus 3 raised to the power y is equal to 3, then dy by dx at x equal to 0 is. Firstly, let us find that what is the value of y at x equal to 0. So, at x equal to 0, putting the value, we get 3 raised to the power 0 plus 3 raised to the power y is equal to 3. That is, 3 raised to the power y is equal to 3 minus 1, that is 2, right? Now, differentiating the given equation, we can write 3 raised to the power x into ln 3 plus 3 raised to the power y into ln 3 into dy by dx is equal to 0, right? So, taking ln 3 common, this can be cancelled. So, we can say that dy by dx is equal to minus 3 raised to the power x upon 3 raised to the power y, right? Now, finding the value of dy by dx at x equal to 0, this will be equal to minus 3 raised to the power 0 upon. Now, at x equal to 0, we have already found out that the value of 3 raised to the power y is 2. So, this can be rewritten as minus 1 upon 2, right? So, the correct answer is option number 4. Next is question number 64, which says that for all complex numbers z1, z2, satisfying mod z1 equal to 32 and mod z2 minus 12 minus 5 iota equal to 13. The minimum value of mod z2 minus z1 is. Now to solve these type of questions, what we do, we draw the coordinate axis and the locus of the given complex numbers. Let us say this is x-axis and this is y-axis. Now the first equation is mod z1 equal to 32, that is, it is a circle centered at origin and radius equal to 32, right? So the circle is something like this. And the second equation have center at 12, 5 and its radius is 13. So the circle will be like this. Let us say its center is A, that is 12, 5. Then the value of OA is 13, that is radius, right? So it is passing through origin, right? And the radius OB of the bigger circle is 32. Now we have to find the minimum value of z2 minus z1. Now the minimum value will lie along OA, right? Let us say this is the point C and this is the point D. So the minimum value of z2 minus z1 is obtained when z1 is at C and z2 is at D, right? So basically we have to find the value of distance CD, which will be equal to OC minus OD. That is, OC is the radius of the bigger circle, that is 32, minus OD is the diameter of the smaller circle, that is 13 into 2, that is 26. So this is equal to 6. Hence the correct answer will be option number 2. Next is question number 65, which says that if limit of x tending to minus infinity ax cube plus bx square minus x minus 1 upon x square minus 2x plus 5 is equal to 2, then the value of a plus b is. Now here in the given question, x is tending to minus infinity, which is a little bit complicated. So let us substitute x equal to minus t so that the limit can be converted to infinity, right? So this can be written as limit t tending to infinity minus at cube plus bt square plus t minus 1 upon t square plus 2t plus 5 is equal to 2, right? So this is what we have been given. Now if I divide the given equation by t square, then what will we get? Limit t tending to infinity minus at plus b plus 1 by t minus 1 by t square upon 1 plus 2 by t plus 5 by t square equal to 2, right? Now here if t is tending to infinity, then in the denominator these two terms will tend to 0. Similarly, these two terms will also tend to 0. So in the denominator we have 1 and in the numerator we have minus at plus b. Now as t is tending to infinity, so the limit is given to be finite value. So this is only possible when the value of a is equal to 0, right? And hence we can say that the value of b will be equal to 2, right? So the value of a plus b, which is asked in the question, is 0 plus 2, that is 2. Hence the correct answer is option number 2.